tragus and the helix. Need to know are going to be funneled down. And when they are funneled down, they're going to be funneled down towards what you call your eardrum. And now I know a lot of you dig earwax, leave your ear alone. Q-tips were not made to dig into your ears. They were invented for clearing stuff out of newborn babies from the outside part of your ear and around the baby's belly button. There are hundreds of kids every year taken to the hospital because well-meaning parents put Q-tips through their eardrums. You can see direction okay. Eardrum, you got to learn the real name for it. It's the tympanic membrane. This is a membrane that's like the timpani of an orchestra. It's going to vibrate when sound waves come in. At the other end, we have this tubular structure right here known as the eustachian tube, which goes to the back of the upper part of your throat. If you've ever had to pop your ears when you're driving up or down a mountain or taking your airplane flight, that is your eustachian tube because it collapses down on itself. And when the pressure changes, you want the pressure here in your middle ear to be the same as the pressure here, the atmospheric pressure. So you do that, and you can bring the pressure here to become the same as the pressure there in your middle ear. All right. So in the middle ear itself, there's three structures that we want to learn about, and those are these three tiny bones. And all three bones together would be about this big, so much smaller than would fit onto a dime. Okay, and so here's what the three bones themselves look like. So this first bone is known as the malleus. It's, in other words, it looks like a mallet, which is kind of like a hammer, has this long handle, which is attached to the tympanic membrane in two places. So when the tympanic membrane vibrates, it causes the malleus to vibrate. And then the head of the malleus is attached to this next bone, which is kind of like a V-shaped flying saucer kind of bone, or shaped like an anvil, and it is known as the incus. And then the incus is attached to the head of something that looks like a stirrup. If you were going horseback riding, it is known as the stapes. And so what happens is between these three bones, the amount of the vibration actually increases 20-fold in the middle ear. Now, I want you to look at this part of the stapes, the part where the sole of your boot or your shoe would go if you had your foot here in the stapes. This is called the foot plate of the stapes. And you see how it is oval? Well, it sits on an opening right here in this bone, right here in your temporal bone, which is the opening between the middle ear and the inner ear. And so this opening that the foot plate of your stapes sits on is called the oval window. And then just below this oval window, there is another opening, a round opening called the round window. All right, so now moving to the inner ear, looking at this picture, at one end, you can see that there are some things that look like almost circles, and at the other end, there is something that kind of looks like a snail shell. So if you took it out and you looked at it, you would see, yes, here's the snail shell, and then it looks like there's another snail shell inside of it. And here is, oh, there's actually 3 of these semicircular things. And then there's an area in the middle. So what this is we have kind of like a maze in the bone. And in that maze in the bone, we have like a lining that goes into that actually follows that maze in that bone. And so the maze in the bone is called a labyrinth. So the maze in the bone is called the bony labyrinth. So here, for instance, let's just like pretend we're looking here at one of these almost circular parts, or here, okay? So here would be the bony labyrinth. And then here would be the membrane following the same pathway. We've been called the membranous labyrinth. Now, inside the membranous labyrinth, we're going to have fluid because in the inner ear, we're going to be changing air waves to fluid waves. We don't have any air in our inner ear, we have fluid. Okay? So inside the membranous labyrinth, we call that fluid endolymph. Okay, not related to your lymphatic system. Lymph is just a word that means fluids. Okay. Now, between the bony labyrinth and the membranous labyrinth, there is also fluid, and this fluid surrounds the membranous labyrinth. So we actually take a prefix that means around, and so this fluid is going to be called perilymph. So we're going to have this all the parts of all these labyrinths. So now we need to give names to both the bony and membranous labyrinths in all these locations. Okay, so at one end, we have the thing that looks like a snail, and we have the round window over there, and then we have that oval window, and we have the middle part, and then we have the 3 almost circles at the other end. So going back to our blown up picture, in the bony labyrinth, the 3 almost circles are called semicircular canals. And the snail structure is called the cochlea. And between the semicircular canal and the cochlea is the vestibule. Now remember, inside the bony labyrinth, we have perilymph. And we also have a membranous labyrinth. So inside these semicircular canals, the membranous labyrinth is called the semicircular duct. And inside the cochlea, the membranous labyrinth is called the cochlear duct. So anytime you see the word duct, you know you're in the membranous labyrinth and not in the bony labyrinth. Now, if you look here in the vestibule, you'll see that there's 2 membranous labyrinths inside the one bony labyrinth known as the vestibule. There's a smaller one closer to the cochlea, and there's a larger one closer to the semicircular ducts. The larger one is known as the utricle, and the smaller one is known as the saccule. They do similar but slightly different things that we'll talk about later. Okay. And also, all 4 parts of this membranous labyrinth are going to be filled with endolymph. So I made this little table, the who's who. Here are the 3 parts of the bony labyrinth, the 4 parts of the membranous labyrinth, and to help you later on, the functions. The cochlea and the cochlear duct are going to give us hearing. The semicircular canals and semicircular ducts are going to give us rotational equilibrium. The vestibule, specifically the utricle, is going to give us gravitational equilibrium in the vertical plane, which means saying yes, which also gives us linear acceleration, which is like pressing on the gas or pressing on the stop. Whereas the vestibule, specifically the saccule, the small one, is giving us the gravitational horizontal plane, which is like shaking your head. Okay, so we'll come back and talk about these functions. We'll do hearing separately, and then we'll do the 3 types of equilibrium as the last video. So I'll see you for the last 2 videos. Thank you. But make sure you know these parts because we're going to be adding to them when we talk about hearing and equilibrium. So make sure you know these parts of the ear first. Thank you so much for all your hard work. See you soon.